And so we just got done looking at triangles. Now we're going to start looking at polygons with any number of sides. A polygon, by definition, is a shape in a plane, so it's got to be contained on a plane, and it's enclosed by line segments that only intersect at their endpoints. And I've got some examples up here. Just a general example. This polygon here has 5 sides. It's closed. It's not open on any side, and the edges are all line segments, and they only intersect at their endpoints. So I have up here a list of things that would not work as a polygon. So you cannot have any curved edges. Okay, so like something like a half moon or something like that would not work. That's not a polygon. Okay, the ones I'm doing in red here are not polygons. Things with an open side, so like if you tried to have 3 sides, like the cross section of a bowl or something, right? If it's got an open edge here that doesn't have an edge or a side connecting it, then it's not a polygon. And you can't have intersections in the middle of these line segments. So like we've seen before, this bow tie sort of shape, that would not work as a polygon. It is constructed out of line segments, but notice there's an intersection in the middle there. That doesn't work. So there's some things that can't work. These are ones that are not polygons. Polygons must be closed off. They must be bounded by line segments, and those segments have to intersect only on the endpoints. Okay. Now we look at regular polygons. These are actually really nice. These are ones where the sides all have the same length and the angles all have the same measure. And so things like your equilateral triangle, where all the angles are 60 degrees, or your square, where all your angles are 90 degrees, or your pentagon, a regular pentagon, which has all equal sides and angles, and the regular hexagon, and you can keep going with that. A regular heptagon has 7 sides, a regular octagon has 8 sides. You're probably familiar with octagons, those are stop signs. But regular polygon, you don't have to be a regular polygon, or it doesn't have to be, in order to be a polygon, right? So this is not a regular polygon, the one I just drew here, but it's still a polygon. Any 4-sided shape like this is a quadrilateral, meaning it has 4 sides. It's not a regular quadrilateral, which would be a square, but it is still a polygon. Okay. Oop, that was in red. Bad idea, right? The ones that were in red were not polygons, and then I drew one that is. Anyway, any sort of quadrilateral. So, another thing, the number of sides determines the name. So if it has 3 sides, it's a triangle. 4 sides is a quadrilateral. 5 sides are pentagons, and so forth. Hexagons, heptagons, octagons. Anyway, so that gives you an idea of what the names are. Now, what's interesting about the actual polygons is that you can split them up into triangles from the corners. Actually, while I'm thinking about that, let's get rid of the other stuff, that isn't a polygon. So essentially, you can always take these and chop them into triangles. And the reason that's useful is because it can, by looking at the triangles, you can actually figure out how many degrees the sum of the angles will be. Okay, so just like we know that the sum of the angles of a triangle equal 180, and because of that, if the polygon here can be split up into 3 triangles, where the corners are the corners of the triangles, then we know that each triangle has angles that add up to 180. And so overall, say a pentagon, right, 5 sides would have 3 triangles. So that's 3 times 180, right? So 5 sides the angles add up, or I should say even 5 angles, might as well go with the number of angles, because they're the same. 5 angles will give you 3 times 180. 3 times 18 is 54. So 540. So you get 540 degrees in a pentagon. Okay. And likewise, if I did a quadrilateral, well, I can split that into 2 triangles, and it doesn't matter which ones I join. I could, instead of going that way, I could go the other way, but it's still going to be 2 triangles. And in both cases, the triangles themselves have angles that add up to 180. And so if you have 4 angles, like a quadrilateral, it will result in 2 triangles, which gives you 2 times 180, or 360 degrees total, right? And that makes sense, right? A rectangle has 4 90-degree angles, which is 360. Okay, and of course, if you have 3 angles, that's our triangle, and that's just 1 times 180, which we know to be 180. Kind of working those backwards, aren't I? But if I wanted to keep going, if I look at a hexagon, it doesn't have to be a regular one, but I already have a regular one up here. You can cut that one as well. And again, it doesn't matter how I cut it as long as the corners of the triangles match up with corners of the polygon, and I'm not overlapping. I wouldn't want to crisscross here. You don't want to intersect those segments on the inside, and so you end up with 4, right? 1, 2, 3, 4 copies of 180. So it's 6 angles. You get 4 times 180. And so you can see basically when you add one more side to a polygon, you're adding one more triangle to the mix here, to the total. 4 times 180 is like 8 times 9 is 720. Think through the factors there. And so you can keep going with this, keep adding 180. So for every additional angle, you get 1 additional triangle, which gives you an extra 180 degrees on your sum of the angles, okay? So, as a general rule, the number multiplying the 180 is always 2 less than the number of angles, okay? So for instance, if I wanted to continue this down to n angles, like use a dummy variable there, get rid of this, then you're looking at the multiplier on the 180 to be n minus 2. Okay, so you're always subtracting 2 from that. So for example, if I wanted 20 angles, a shape with 20 angles, I know that that's going to have 20 minus 2 times 180, which is 18 times 180. 18 squared is the same as 81 times 4, which is 324. So that's 3,240 degrees. That sound about right? Let me double check that. 18 times 180. Oh, I just did divided. Come on, times. Yeah, 3240. Cool. Okay, that's right. Anyway, so you could add up the angles of any 20-sided figure, and it's always going to give you 3240, 3,240 degrees. Okay, so that's the sum of the interior angles. So this is the formula for the sum. Right there, formula for the sum of the interior angles. Okay, so it all depends upon the number of angles on the polygon. Okay, so those are kind of fun. In addition to that, we're also going to look at perimeters, which I'll talk about in the next video.